All right, let's take a gander at number 7. I don't know. Eliminations kind of could be used here. I'm probably going to do substitution on this. And I like substitution because if I look at that x, it's all by itself. If I add 3y and add 3y, makes a 0 right there. So now I know that x is always going to be equal to negative 5 plus 3y. So anywhere else I see an x, which is this x right there, I can replace it. So now I have 4, and instead of times x, now I can write down negative 5 plus 3y. Close the parenthesis, and don't forget, a lot of students forget to write the rest of that stuff in there. Don't forget, you're going to need that stuff too. So then minus y equals negative 9. Next move, distributive property. Let's multiply those together. So that'd be negative 20 plus 12y minus 1y equals negative 9. Ooh, look, like terms. No. Let's combine those together. So now I have negative 20, 12 minus 1 of those y's would put me at positive 11y. Let's add 20. And, ooh, what a coincidence. I think negative 9 plus 20 would put you at positive 11. So then dividing both sides by 11, y should be 1. Box. Here's the awesome part about substitution, ladies and gentlemen. We have some math in a box right there. Y equals 1. We have some more math in a box right there. Wouldn't that be able to tell us what x is right there? Let's do that. So then I could figure out what x is right up here by just figuring out what negative 5 plus 3 times 1 would be. So that'd be negative 5 plus 3. And then negative 5 plus 3, I believe that's a negative 2. Could we check this work the same way we checked the last one? Yep. So save some time, just because you're just looking at this to see how to do some of these problems. I'll leave the checking to you. All right, let's look at this one. Negative y and substitution's kind of out. Let's do elimination on this one. And let's go ahead and take that bottom equation. Let's multiply it by 2. See why 2 would be awesome on this one, because then if we multiply by 2, the y's will be able to eliminate with these y's up here. Okay, so if I do that, let's copy this down over here. Let's not change the top. Once again, I think I'm doing elimination, so let's get rid of this. We don't need any of that. Goodbye. And then multiplying that by 2, that would put us at 10x minus 2y equals 34. Alright, let's add. So that would put us at 8x, and then negative 10 plus 34 would put us at 24. See how quick and easy that first answer can be with elimination. So now they know that x is 3. Let's use that top one up there. So top equation, negative 2x plus 2y equals negative 10. Negative 2 then times 3, because I know x now is 3, plus 2y equals negative 10. That's negative 6 plus 2y equals negative 10. 2y, sorry if I'm not doing the algebra steps here, but realize the algebra step here would be adding 6 to a negative 10, which would put us at negative 4. And so then dividing both sides by 2, we should be at negative 2. Ding! Alright, last but not least, this linear programming setup here. After we read all this situation and read all these constraints here, and then also some cost here, the first thing they want us to do is write the constraints, and then write the objective function for minimizing the cost of production. There's really no real requirement for you to do it in that order. You know, what I'm looking at right here, because at the problem, isn't it our objective to minimize the cost of production? Notice right here it costs $12 to manufacture the flying bat, $8 to build the flying falcon. Okay? Try and catch that. And if we define x to represent the number of flying bats, and we let y represent the number of flying falcons. We could come up with an objective function pretty efficiently. And it would go a little bit like this. Doesn't matter what variable you use here, I'll just use C for cost. And then wouldn't it just be $12 per bat plus $8 per falcon? Let's go back up here and take apart the constraints. Because of lack of materials, no more than 40 flying bats can be built. No more than 60 flying falcons can be built. Couple things to keep in mind. Number one, realize that you have this limitation here is that you, and they usually don't ever state this, is that you have to have a positive number. You've heard me talk about this before in class. So one thing that must always be true is that your number of bats or whatever it is that you're producing, your variables have to be positive. Now watch this slick little move. Then I'm going to take these two and combine it with the fact that we can't produce any more than 40 bats or any more than 60 falcons. So doesn't that kind of mean that the number of bats I can make has to be between 0 and 40? So couldn't I write this as a compound inequality? And I would say that 0 needs to be less than or equal to x, which needs to be less than or equal to 40. And then I can do the same thing with the flying falcons. 0 needs to be less than or equal to not x, but y, and that needs to be less than or equal to 60. Okay? And then what else are I saying here? There are enough workers to build at least 70 airplanes. And I think what they mean by the Tory airplanes is that it could be a combo of flying falcons combined with flying bats. Careful with that phrase at least. A lot of students might misrepresent that with a less than symbol. But if you want to make at least something, that means you got to make that or more. So the number of bats plus the number of falcons have to be at least 70. So they're greater than or equal to 70. And right there, you've just written all the constraints on this problem. And we've also written the objective function. So I hope that helps. I'll also have a static copy of this online too in the same usual location. All right, happy studying.